So what we have on the board today is vectors and what? Scalars. Vectors and scalars. A scalar quantity, you can write. A scalar quantity is a physical quantity that has only magnitude, no direction. A scalar quantity is a physical quantity that has only magnitude, no what? Direction. Why a vector quantity has both magnitude and direction. A vector quantity, a physical quantity that has both magnitude and direction. So, if we have a body moving from point A straight to point B, from point A to what? Point B, we say that the direction from A to B, this is a vector quantity because it has an arrow head. And this arrowhead shows that it has a direction. So it's going from A to B. And now, this is a vector because it has a magnitude, which is the size. It has a magnitude, which is what? The size. Let me be right. Now, when you now talk about scalar, you'll find out that a point, you see, to another point B, if a man moves on this kind of path, it is a scalar quantity because it has no direction. It has no what? Direction. There is no arrow. So you don't know whether it's actually coming from here or from there. So there is no direction. That means this is a scalar quantity. It has only magnitude, the size. So when we talk about magnitude, it always shows us what? Size. So we have now understood what a vector is and a scalar is, Abi. Good. Let's look at examples of scalar quantity. What are the examples of scalar quantity? An example of vector quantity. For a scalar quantity, we have scalar quantity. Examples are what? One is what? Speed. Two is what? Distance. Three is what? Time. Four, length. Five, mass. Six, temperature. Good. All right. So these are scalar quantities. Now, let's see if we can have examples of vector quantities. Vector quantities. Examples are what? One, velocity. Two is what? Displacement. Then three is what? Acceleration. Acceleration. I hope you are getting the point. Four is what? Force. Five is what? Weight. Six is what? Torque. All right, so we have many, but let's pick this. Now, we have known examples of scalar quantities and vector what? Quantities. What is speed? Speed has only magnitude. Distance has what? Only magnitude. Time, only magnitude. You cannot say the direction of time, or do you? It has only magnitude. You don't have the direction of length. We just take the magnitude of length, same as mass. Mass is a constant. Okay, it does not have a direction. Temperature does not have what? direction. But if you talk about velocity, it has direction. Velocity is the rate of change of displacement with time. Now, that displacement has direction because displacement is what? Distance in a particular what? Direction. Acceleration has direction because acceleration is the rate of change of what? Velocity with time. So as acceleration has direction, force also has what? Direction. Because force is equal to mass times what? Acceleration. Even though mass does not have direction, acceleration has what? Direction. Then weight is equal to mass times acceleration due to gravity. Do you know that the weight of a body is equal to the force of gravity? Okay? The force of gravity, that is the weight of a body. So weight is equal to mass times acceleration due to what? Gravity. Torque is what? Force times radius. Force times what? Radius. So force has direction. Radius does not have direction. Talk about resultant, we are actually talking about the sum. We are actually talking about what? Sum. So the first case is called parallel vectors. It's called what? Parallel vectors. Two vectors are said to be parallel to each other if the angle between them is 0. Two vectors are said to be parallel to each other if the angle between them is 0. I hope that one is clear. Now, the resultant of parallel vectors. The resultant of parallel vectors is the arithmetic sum. The resultant of parallel vectors is the arithmetic sum of the individual vectors. The resultant of parallel vectors is the arithmetic sum of the individual vectors. So if we have vector A, for example, and vector B, for example, so the resultant vector is kind of the resultant effect. So we call the resultant here R equal to what? Vector A plus what? Vector B. This is the resultant of A and what? B. The resultant of A and B is vector A and vector B. You sum it together. All right? That's the resultant of vector A and vector B. Now, in these two, angle theta is equal to what? 0. So when theta is equal to 0, automatically you already know that they are parallel vectors. They are what? Parallel vectors. So let's take an example. If vector A is 50 Newton and B is 30 Newton, both act on an object. Calculate their resultant vector. So what will you do in this case? If vector A is 50 Newton and vector B is 30 Newton, both act on an object in the same direction. They both act on an object in the same direction. Calculate their resultant vector. Please, I want you to take note that for parallel vectors, the two vectors act in the same direction. As you can see, the two vectors act in the same direction. Hence, their resultant vectors becomes the arithmetic what? Sum. So, if vector A is 50 Newton and vector B is 30 Newton, both act on an object in the same direction. Calculate their resultant vector. Solution, what will you get? Solution, you say that resultant vector is equal to vector A plus vector B, right? Eh? So what is vector A? 50. What is vector B? So 50 plus 30 is equal to what? 80 Newton. So this is how you calculate when two vectors are parallel to each other. I hope it's clear. When two vectors are parallel to what? Each other. Now let's look at anti-parallel vectors. Two vectors are said to be anti-parallel to each other. Two vectors are said to be anti-parallel to each other. Two vectors are said to be anti-parallel to each other when they act on an object in opposite direction. When they act on an object in opposite direction. When they act on an object in opposite direction and the angle between them is 180 degrees. When they act on an object in opposite direction and the angle between them is 180 degrees. So let's look at this. This is the object. Now, this is pulling this object this way. This is pulling it. This is vector A, and this is vector B. Now, the resultant vector on this becomes the arithmetic sum, arithmetic subtraction. The resultant of anti-parallel vectors becomes what? Arithmetic subtraction. So you now see that resultant here is equal to A minus what? B. So for anti-parallel vectors, the resultant is what? Arithmetic subtraction between the two vectors. I hope you got that. The resultant of two anti-parallel vectors is the arithmetic what? Subtraction. The arithmetic subtraction. So given that two forces acting in opposite direction, two forces acting in opposite what? Direction, have magnitudes 80 Newton and 20 Newton respectively. If the angle between them is 180 degrees, find their resultant displacement. So what will you do? You say solution again. What do we do? Resultant displacement for anti-parallel vectors. Hope you know they are anti-parallel vectors. Why? Because they act in opposite what? Direction. And again, the angle between them is what? 180 degrees. So when they act in opposite direction and the angle between them is 180 degrees, they are anti what? Parallel. Their resultant must be what? Arithmetic subtraction. Arithmetic subtraction. So we now have it as what? A minus what? B. So what is our A here? 80. What's our B there? 20. So that 80 minus 20 is what? 60 what? Newton. So this is our final what? Answer. It is very important you take note of this. Now, when we talk about vectors that are perpendicular to each other, we need to take note of one thing. Number one, if vector A and B are perpendicular to each other, then the resultant vector will be r squared. We apply Pythagoras theorem. The resultant vectors, we apply Pythagoras what? Theorem, which is r squared is equal to what? A squared plus what? B squared. So we use this method to find the resultant what? Vectors. So we can now say that r is equal to what? Square root of what? A squared plus what? B squared. So this is what we mean by saying that two vectors are perpendicular to each other. And the angle between them must be what? 90 degrees. The angle between them must be 90 degrees. They must be at right angle triangle to each other. Okay? So like this, we can say that we can use the cardinal point bearing to describe it. What do I mean by cardinal point bearing? Here is north, Abby. Here is south, right? This side is what? East. And here is what? West. So, as it implies, we can say that this is at right angle to each other, Abby, angle 90 degrees. So, if they want to give you a question that befits this topic, perpendicular vectors, they must say a man travels due north and then due east. Do you understand? Okay. This will enable us to solve this second question. A man travels 7 kilometers due north and 10 kilometers due what? East. Have you seen that this question can be easily solved now? Understanding perpendicular what? Vectors. So we are going to take this question as an instance to what we are going to do right now. I hope it's clear now. So from here, on perpendicular vectors, a man travels 7 kilometers due north. You draw the cardinal points bearing again. This is north, Abby. So this is north. A man travels 7 kilometers due north. 7 kilometers. Pay close attention to this. 7 kilometers due north. Have you seen it? I am done with this part. And then 10 kilometers due east. Shey, if you draw north east here, Abby, this side is east. You extend it. 10 kilometers due east. Are you following? Now, the resultant, because you say calculate the resultant, you join from the origin, okay, to this point. Where they meet, this becomes the resultant. It becomes what? The resultant. Here is angle 90 degrees, Abby. The angle between 10 and 7, that means we are applying perpendicular vectors law. Because they are perpendicular to each other now. They are at 90 degrees to each other. Hence, perpendicular vectors. Perpendicular what? Vectors. So to get the resultant, you simply say R all squared is equal to what? 7 squared plus what? 10 squared. Have you seen? It's very easy. The moment you notice that they are perpendicular to each other, you apply this law to it. Have you seen it? So from here, you now say that R is equal to square root. 7 squared is what? 49. 10 squared is what? 100. R is equal to square root. 49 plus 100 is what? 149. Square root of 149. R is equal to what? 12 point what? 2. So we have gotten this. Now, let's look at the direction. This is the magnitude. So how can we get the direction? We have just obtained the magnitude. How do we get the direction? Are you following? How do we get the what? Direction. This is right angle triangle. Hence, we talk about SOHCAHTOA. Have you heard of SOHCAHTOA? So we can use this to get our angle. Our target is to get this angle. The direction is from here to here. Are you with me now? Here is what? Theta. Opposite is what? 10. Adjacent is what? 7. Which one of these has opposite and adjacent at the same time? Tan. I will now say tan theta is equal to opposite over what? Adjacent. Opposite over what? Adjacent. So opposite is what? 10. 10 over 7. Are you with me now? So now, we say tan theta, which is equal to, divide. What do you have? 10 divided by 7 is what? 1.42 what? 8. Then you punch theta is equal to tan inverse of 1.428. Theta is what? 55 point what? 0 degree. Okay. 55.0 degree. Now, we have 55.0 degree. I want to show you something. Do you notice that this arrow is moving from north towards east? It's going from north towards what? East. Are you getting the diagram? So now, here is moving from north to what? East. So 55 degree north, east. So the displacement is 12.2 kilometer, 55 degree north east. You can just write it 12.2 kilometer, comma 55 degree north east. So that is the answer for this question. I hope it's clear. Good. Because we are talking about perpendicular vectors, we have a condition also for perpendicular vectors. For perpendicular vectors, if two vectors are said to be perpendicular, their dot product will be what? 0. If they are perpendicular to each other, their dot product is what? 0. What do we mean by dot product? Now, we have what we call if vector A is equal to AXI plus AYJ plus A what? AZK. Now, we are talking about vector B equal to BXI plus what? BYJ plus BZ what? Okay. So when we say two vectors are, as in if two vectors are perpendicular, if their dot product is 0, we are actually referring to these vectors. So you have to see how we talk about multiplication of vectors. Multiplication of what? Vectors. This is seen as a vector. This other one is also seen as what? A vector. It has magnitude, which is component, and direction. Magnitude and direction. So this thing is a unit vector, a unit vector, a unit vector, a unit vector, and also a unit vector. If a vector is represented like this, and now they are asked to find the dot product, the what? Dot product. What will you do? A dot B is equal to, because I dot I is equal to 1, I dot J is equal to 0, I dot K is equal to 0. Anytime AXI multiplies, it's multiplication of vectors. Are you getting it now? If AXI multiplies BXI, you'll be seeing I dot I, Abi, because this is dot. Are you following now? This is A. A is AX, I. This is B. B is BX, I. So if you now say AXI dot BXI, you will see a common term, I dot I. Are you with me? So what is I dot I? What is I dot I? What is J dot J? K dot K is what? I hope that one is clear. So I dot J is 0. I dot K is 0. J dot K is what? 0. So anytime I mixes up with JK, it will be automatically what? 0. Anytime I mixes with JK in A, it will be 0. So the summary now is finding A dot B, I will only have identical unit vectors. So I dot I, 1, Abi. So what gave us I dot I? AX and BX, Abi. You bring it together. AX, BX. Because these two have what? I dot I. This times this, AX, BX. I times I dot I. Now, plus, I'm supposed to say AXI times BYJ. Are you getting it now? But because I dot J is 0, this AXI will cancel out BYJ because 0 can cancel out anything. AXI will cancel out BZK because I dot K is what? 0. I will now go to the next one, AYJ. So I will go straight to AYJ. I will look for the one that has J so that it will stay. Are you with me now? So this one has J, right? Which is what? BYJ. So I will say AY, BY into brackets, J dot what? J. Who can tell me what I will do next? Plus AZ, BZ, K dot K. Do you know that K dot K is 1? I dot I is 1. J dot J is 1. Every other one will be what? 0. That's why you see that everything has been reduced to this. So that A dot B, okay, this is dot product. It's called what? Dot product. A dot B is equal to AX BX plus what? AY BY plus what? AZ BZ. So this thing now is very, very important in finding the dot what? Product. Very important in finding the dot product. All right. Let me give you a quick question on that. If A is equal to 3I plus 2J minus 5K, okay, B is equal to 2I minus 4J plus K. Find A dot B. Can you tell me the answer? What will you do? Say this one, 3I, 2I is here. So 3 times 2 will give me what? Say I'll write 6, Abi. I dot I is what? Minus times minus, minus times plus. 2 times 4. J dot J is what? Say the next thing is this one, Abi. Minus 5 times plus 1 is what? Minus 5. So now 6 minus 8 is what? Minus 2 minus 5 is what? So I'll now say A dot B is equal to minus what? 7. Do you see it, how simple it is? We just apply this to solve this question, and you got your answer. I hope it's clear. I hope it's clear. You have a question? How did I not put? I dot I. I dot I is 1 already now. No need, because it's already 1. Have you copied this? Okay. We have another question. When we touch this question, we are done with resultant vector. It's recording now. All right. So in the question, it says two forces having magnitude and 5 Newton and 4 Newton have an angle of 30 degrees between them. What is the scalar product? Shall I told you something about scalar product here now? See it here. A dot what? B is scalar product. But we have another way of addressing scalar product, which means we have A magnitude, B magnitude, cos what? Theta. This is called scalar product. It's called what? Scalar product. This is called scalar product. A dot B is equal to this. Now, again, we have that in this case, two forces, let A be one force and B be the second force. Are you following? So now we are talking about two forces having magnitude 5 Newton and what? 4 Newton. Have an angle of what? 30 degrees. What will you do? We have different ways of solving, but they say find the scalar product. If they say find the resultant, it's different. But the question says find the scalar what? Product. And the scalar product is what? Is A dot what? B. So what is A? A is what? Not ordinary A, but magnitude of what? A. See the word here, magnitude. And this is the symbol for what? Magnitude. And we have magnitude of B is what? 4. See magnitude here. And the angle between A and B is what? 30. I hope it's clear now. Can you solve it on your own now? So what do? Magnitude of A is 5 times what? Magnitude of B is what? 4 cos what? 30 degree. So theta is 30 what? Degree. So from here, 5 times 4 is what? 20, Abi. And cos theta is what? Root 3 all over 2. Root 3 all over what? 20 divided by 2 is what? 10. So our A dot B is equal to 10 root what? 3. Do you get it now? You got it? Correct. So that is very, very correct.